Hey guys, Yug from Team Super 7 477. Welcome to part 2, where we'll talk about math libraries. This will be a more long of a lesson since there's lots of math libraries to talk about. Since we've downloaded Java in the first lesson, you may be able to use that. It's way easier to not be able to memorize all of these. But today I'll be using Replit to show you it's not very hard to memorize all of these. So let's start out with the easier ones. For example, math.pi and put pi in all capital letters. That should be printing out the number pi. There we go. Now we can also do the same with the number e. Nice. Now let's do add exact. So you want to add and then put the E in capital, exact. Now you want an extra set of parentheses and 3, let's try any number. So let's try 3, 4. Now we've gotten 7. What if you want to get the arc sign? We can get the arc sign from any number between -1 and 1 using a SIN. And then in the parentheses, let's try 1. Now let's run it. Nice, now we got the arc sign. Now let's do arctangent. So let's switch SIN with TAN, which represents tangent. And let's try this number 3. There we go. We should be getting the arctangent. Just give it a second and it should be giving you your arctangent. Now before it loads, let's just talk about arctangent 2, which is our next one. It basically is arctangent squared and converts regular coordinates to polar coordinates. Now that we've done that, let's do what we were just talking about, arctangent squared. Again, converts regular coordinates to polar coordinates using the angle of x and the y point. It looks like there is a okay, yeah. So make sure to put a comma here. So let's just try 6, 3. And then it will work. That's just a slight error you need to take care of. And let it load. And we have gotten our answer. Let's do cube root now. So cube root is CBRT. CBRT, and let's find the cube root of 9. Oh, and sometimes you might accidentally hit the enter button, so that'll happen. Wait for that to load. And nice. Okay, now let's talk about seal, which you round up. Seal, which helps you round up. Let's round up 9.3, which should give us 10. Wait for that to load. And there we go, we have 10. Now let's try copy sign, which I think it's a pretty interesting. Copy sign. There we go. So make sure to put commas in between your numbers while using copy sign. Let's try 4, comma, -2. Now, the negative sign should be going to 4 and therefore printing out -4 in your console. There we go. Now let's try making this a -2. And now we have negative. Okay, now let's do the cosine. Let's find the cosine. This only works for any number between -1 and 1. So to find the cosine, just put cos, C-O-S, and let's say 0.3. Let's find the cosine of 0.3. And just give it a sec to load into your console and we'll print it out. There we go. Now let's find the hyperbolic cosine. So to find the hyperbolic cosine, just put COS and put in H. There we go. You can actually spell out Kosh. Wait for it to load in your system. There we go. We found the hyperbolic cosine. Now let's find decrement exact. Decrement exact. We've gotten an error. I'm pretty sure you may need a colon between your numbers. So, decrement exact 3, 5, let's say. And wait for it to load into your console. There we go. Now we've done it. Okay. Now let's do e raised to the power. So I'll just put exp. So to test this works, let's just do 1, which will give us, obviously, e. We'll give it a sec, and it should load in. There we go. Now let's raise it to the power of 7. Should be getting 1,000 something. There we go, 1,096. Now, we have floor, which rounds a number down. A way to remember ceil and floor is think of ceiling, which is up, and floor, which is down, which can make you remember round down and round up. So, floor 7.8. And there we go. We have gotten 7. Now let's do floor division. Let's do 15, 4. We should be getting our answer. Perfect. And what about floor mod? So do floor mod. Not too sure on what this does, so should be printing out our answer. Perfect. And let's get the unbiased exponent. To do that, let's do get exponent. So right here, you want to type get exponent. Get exponent. And let's get the exponent of 15. And there we go. We got the unbiased exponent. Let's get the hypotenuse. To get the hypotenuse, you want to just do HPOT, hypot. And let's put some x and y coordinates. For example, let's try 3 and 4. Wait for that to load in. Oh, make sure to put a y. I accidentally forgot that part. And now it should work. Sorry about that. And there we go. We have gotten our hypotenuse of 5. Now let's find the log of e. To find the log of e, you want to just put log where you put hypot. Log. And then put math.e inside of your parentheses. There we go. So now let's get our answer. So give it a sec to load into your console, and you should get your answer. There we go. We've got 1. So let's find the log base 10. So just put log 10 right there. And then let's say 12 inside the parentheses. And we should get our answer. And there we go. So now we can do return max, which returns the maximum number inside of your parentheses. If I put 12 and comma 16, it should be returning 16 because that's the maximum number. And there we go. But now we also have minimum. So to do minimum, just put min. And it should be printing out 12 since that's the minimum number it can go to. There we go. We have gotten 12. So now, let's do multiply exact. So, multiply exact. Let's keep the same numbers. Nice, we've gotten the right answer. Now, let's do negate exact. Inside the parentheses, let's just put a random number, for example, 43. Now let's do negate exact. Negate exact. And then we'll get our answer. Perfect. Now, let's do next after. So, first type it in. Next after, let's just put some random numbers in. For example, 31.432, comma, negative 5.4. Nice, now we got our answer. What about next down? We'll do next down. Make sure to capitalize the D like how I didn't. And let's put some random number in there again. Um, 43. And boom, we've got next down. Now let's do next up. There we go. Now let's get the exponent of some numbers. To do that, write POW. P-O-W. POW, and let's say 3, 4. 3, 4. And let's get the exponent. There we go, we've got an 81. Now, one of my favorites is random. Gives you a random number within the range of 0 and 1. Just put random and put some empty parentheses. Well, nothing in them. And after this video, just make sure to play around with them more. Play around with all these math libraries. That way, it gets stuck in your head. Okay, now that we got our random number, let's try rint. Which basically rounds a number. Rint, let's say 8.6, should round to 9. Give it a sec. Perfect. Now let's round it down to 8 by using 8.3. There we go. And the same thing happens when we use the round. It should round down to 8 again. And if we change it to 0.6, it will obviously go back to 9. So now let's do a scal B. So basically, it calculates the formula of D times 2 by the scale factor of 2. Basically, so you want to put any number. So let's try 2, which will be multiplied by 2, which is 4. By the scale factor. So let's try the scale factor of 1, and this should return 4 since the formula is D times 2 with an exponent of 1. Oh, we forgot to change back this. So let's change that back. In order to get this formula, do scale B. And then we should get our answer as 4. Perfect, we've gotten our answer as 4. Okay, almost done. So, let's do something, a function that can return the significant number. So, in order to do that, write SGN, sign singum, basically, kind of like that. And let's do 2. It's supposed to be a single number without a comma, I'm pretty sure. I'm not too sure on this one. I don't use it that often. And yeah, there we go. We found it. So now let's do something that can return a sign between the numbers of -1 and 1, which is SIN. So let's do that. And I'll choose a random number, like I'm gonna do here. There we go. And we should get the return sign. There we go. We've gotten a return sign. Now let's find the hyperbolic sign by doing sign H. Getting our hyperbolic sign. Give it a second again. And there we go. We've gotten our hyperbolic sign. Now let's do the square root, which is SQRT. Inside the parentheses, let's put 9. There we go, we've gotten our square root. Now let's do subtract exact. Subtract exact. There we go, let's do 9, 2. And we should get the exact. Next up, we'll be talking about the tangent right after we get this number, 7, okay? Now to get tangent, just put TAN. Okay, once we have put TAN, put something to find the tangent, some random number, like I'm going to do here, 4, 3. We should be getting the tangent. And next up, we'll be talking about the hyperbolic tangent and how to get that. There we go. So to find the hyperbolic tangent, let's just put a random number in the parentheses again. Like 0.3, how I'm going to do here. Then replace that with an H. There we go. Nice. Now let's do 2 degrees. You basically in the parentheses, you put an angle and it will translate into, you put an angle in radians, and it will print out the radians and convert it into degrees. So let's do 2 degrees. Put that in parentheses, and put 0.45, and I'll turn that into radians. Degrees, sorry. Looks like there is an error. Not too sure what the error is here. But yeah, you guys at home can just test it out really quick and check it out if it doesn't work on here. So yeah, let's just move on to 2int exact. So this one is kind of a little bit more special. Oh, I've found out what is wrong for 2 degrees. I just need an extra parentheses. Okay, now we should be getting the right answer. Yeah, there we go. Moving on to 2int exact. So it's a little bit different. So we want to do 2, let's first type it in, 2int exact. There we go. And then put these parentheses, and inside the parentheses you want to put another pair and put long inside of it. Outside of it, leave space and put any random number. I'm going to put 6.5 and we'll turn it exact. Give it a second. There we go, we've got the exact. And just 2 more math libraries left. There we go. Okay, so 2 radians. So put the angle in degrees inside the parentheses, and then the console will print it out as degrees. So radians 90. Let's put 90 degrees, and that should be converted to radians. Oh, make sure not to capitalize it. Looks like there is an error here. Oh, 2 radians, my bad. And we should be getting it in degrees now. I'm pretty sure there shouldn't be any more. Okay, one last error. Okay, finally. It should work now. Oh yeah, there we go. Now our final last one, OP. So to do this, just put OP. Just give it a sec. There we go. We found the OP of 9. And OP is just a positive difference between the floating point number and the double next larger in magnitude. Okay, so that's all for this video. Thank you guys so much for watching. I hope you guys learned a lot. Thank you.